Hello and welcome to week one, which is chapters 1, 2, and 3, I believe, of the BDF book, the Big Data Foundation book. One way to think about big data, and it's hard because we can't always see big data, but I love this quote. Without big data, you're blind and deaf in the middle of the freeway. And it's so true because we're trying to get data-based decisions. We're trying to figure out what works and what doesn't based on data, not on bias or gut feeling, things like this. So that's why big data is so important. So we're going to talk about the significance of analysis. Sometimes, or how did we get here? Why do we have big data? The digital turning point, and it's 2002-ish, okay? A couple different frameworks, business intelligence, and the book uses the 5 V's, but there's 10 V's, 4 V's, 3 V's. As long as you get the general concept, you'll be fine. Okay, so the learning goals. So we're going to move this over here. Define big data. What is big data? And that's different to everyone. Identify primary sources. Identify specific data challenges. Focus on overarching concepts between the why behind the data rather than just memorizing the 5 V's. And that's why I really emphasize, I think it's on the next PowerPoint, that there's 10 V's, 4 V's, 3 V's. It's just this nebulous thing, but if you get the concept, you'll be fine. Can't go to the next slide. There we go. Sorry about that. So where does big data come from? And it comes from everywhere. Sensor data, like your watch, cell phone data, TVs now. I have a TV over the corner and it samples a few thousand times, I don't know, a minute, a second, see what I'm watching. Social media, not only what you post, where you post from, how often you post, what device you post from. I mean, there's all this data that's just being captured. There was just an article about how McDonald's has these huge profiles on their customers. The Internet of Streams, smart home devices. I have a smart thermometer on Google Home, used to be Nest. I'm sure it captures the internal temperature, humidity, when I touch it, all types of data hundreds of times a day. That's just one different type of device. There's hundreds of them. Business transactions, in healthcare, we have claims, and there's thousands of claims. It's just a massive amount of data. Digital content, I have a slide, I don't know, 2 or 3 slides down that, we used to have to take a VHS tape, put another VHS recorder, hit play and hit record. Now we can just copy it instantly. Public records and governments, we have more population and we have more data and we have more census and more of it's being shared. Also, there's, we graduate more PhDs, we graduate more scientists every year, so we're generating more derived data all the time. There we go. So the original one I had in here was, if we look, we had an author, maybe Stephen King or any author. I use the author of one of the books. It might take 6 months to write a book. You sit down, you type, and you spend 6 months, and that might be 100 megs of data. Now, you have a satellite flying over you, and it takes boom, 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 hundreds of images a minute. And all that data in that satellite is just an immense amount of data. And so that is really one of the changing points. You have your phone, and you're driving down the street, and you record. I don't encourage you to break the law, but you record, you driving to UNLV, and now you have, where the fire hydrants are, where the stop signs are, where the lights are. Just an immense amount of data, and it's 2 or 3 minutes of video just trumps just anything that a person could write in a year. And your book kind of makes the inference that 2002 was a turning point, okay? And there's research that says, hey, the amount of information we have doubles every 2 years, 5 years. And it's hard because I don't know if any of those numbers, the numbers are correct, but the amount of information that's doubling is very scary. Because how do we process it all? I read somewhere that, I'm trying to think what it was, that every year now we generate more information or more data than the last 10,000 years of recorded history. So we're just generating this massive amount of data. And how do we process it? How do we store it? Is it good or bad data? If I take a picture that's blurry, does it have value? Does information that is just missing information good or bad? And here's kind of, you can kind of see where this happens, and if I have a cassette tape, I put one cassette tape in, an analog cassette tape, put a cassette tape in, have another cassette recorder, hit play, hit record, and I have to copy that information that way. If it's a 30-minute cassette tape, it takes 30 minutes to record. If I want to do 5 copies, it takes 30 minutes to play, or 6 copies, let's say, it takes 3 hours to record it. That's 3 hours of my time. Now that the word's digital or more digital, I can take an MP3 file of maybe this class or a meeting, copy it 6 times, and I'm out, a half a second. So we're getting to a stage where we're copying and producing and generating more data than ever. And going on that, I have an Excel file, I give it to you, you make a few changes, and then you give it to somebody. It's just so easy now to duplicate data, and to create new data. So one important thing that we have to kind of keep in mind is the level of analytics or the level of prediction or what we're doing. We have descriptive analytics. And I have slides on each one of these. But descriptive analytics just describes what you did. So when I was an undergraduate, my GPA was, 3.8, 3.75. That describes something in the past. Diagnostic analytics. Maybe my math GPA was X, and maybe my English GPA was Y. So it describes, it goes into a little more detail. Predictive analytics. Well, if you look at my high school GPA, my undergraduate GPA, my master's GPA, my PhD GPA, they all got better. Each one of them got better. So in theory, if I ever got a degree after my PhD, I would have a better GPA because it's a nice, clean line. So you're kind of predicting what will happen. And then prescriptive analytics, this is one that's kind of hard for a lot of people to understand, but how can we make it happen? How can, predictive kind of tells like the linear regression. So we know that next week, let's say I own McDonald's, we know next week we'll sell 5 million hamburgers at McDonald's. Prescriptive analytics says, hey, if we do this, we might be able to make 6 million hamburger sales. So it's the next step. This goes in a little bit more detail of that. And so here, descriptive analytics uses summarize, interpret historical data. What my GPA was in the past. What happened and why. Diagnostics tries to find the reason of this. Predictive tries to predict what happens, kind of maybe without any change. And prescriptive tries to say, if I do X, I'll get Y. Let's keep going. Now, the term, the 5 V's of big data, as I said before, there's a bunch of V's. It just really depends on how you define it and what words you use. And I hate to say it, but it's true. The 5 V's are maybe a very common one. I've learned the 3 V's, but I've seen, and I have a few charts that show 20 V's or 10 V's. So it can always change. So don't get hung up on one particular V. I know that sounds weird. Volume. So volume is how much data you have. That could be different for each person and the type of data. But one of the V's is volume, how much you have. Velocity, how fast is it coming in? Is it updating every second? You're getting 100,000 updates a second. You get 1 million updates a second. You're getting 1 update a day. Variety, is it all the same type of data or is it different data? Maybe you're doing telephone stuff, like recording transcripts. You work at a pharmacy and you want to record the transcript. You're getting audio from the customer speaking. You're also getting what prescription they picked up, getting when they picked it up, who they paid for, things like this. Veracity is the change to ensure that data quality is distinguished from the signal noise. So the idea is that is the data good enough to produce intelligence? Value. Is what you're getting valuable? And I know this sounds dumb, but sometimes recording things has no value now and probably will have no value ever. Okay? If you're looking at, you run Walgreens or CVS, and you want to know how you can have people buy more bottles of water when picking up their prescription. So you start collecting a data set, start making a data set, okay? And then you realize that, hey, you don't make any money on water, number one. Number two, the data you're collecting, whether the person's left-handed or right-handed, maybe has no value if they buy water. You grab all these other data sets and it just has no value. It's a valueless data set. And this happens a lot. A lot of companies grab data just because that's what we were told to do as a company, grab data, and it has very little business value. And sometimes some things have a lot of value and we don't realize it. Data perishability. So if you have data that's 10 years old, is it worth as much as data that's 5 years old? Sometimes yes, sometimes no. You have prescription, you're trying to predict the next prescription a person will fill. So somebody gives me a job and says, hey, we want to know, so that way we can stock the pharmacy correctly, we want to know the next prescription. I work at Walmart and I want to know, hey, what's the next San Francisco rice-a-roni that the person is going to buy? Well, I have data from the last 2 weeks, last month. That's probably valuable. That probably will help me with data perishability. I have data from 17 years ago. Probably not going to help me. Yeah. Yeah, the original pillars. Yeah, the list has gone to 56 variants, which is crazy. And I'll go to the 56 here in a second, and I'll get back to semi-structured. So this is a real simple one that I always try to keep in mind whenever I'm working on the project. How fast is the data going? How fast am I receiving data? Because it defines, what type of storage I need, what type of data processing I need, what type of computer I need. What type of data is it? Is it just text? Is it video? Is it pictures? What am I receiving? And how much do I plan to store? How much do I have? Oops, here's another one. Here's the general one we looked at. Oh, look, the 6. Ooh, that one's 8. So getting bigger. Look at that one. There's a 56 one. They're all V's. Somebody didn't have much of a life to come up with 56 V's right here. It's a lot of V's. But they're all important. I'm not going to argue with that. But let's go back to this slide right here that I kind of jumped over. So this is kind of a hard concept to understand because it's all on a computer, so it's all organized. Not necessarily. So structured data. One of the ways to think about structured data is it like in an Excel? You have rows and columns. I have a member ID. I have a call start. I have a call end. Another example, hey, I have a dog name, Poodle, and then I have when my dog was born and when my dog died. Luckily, he's still alive. I have his weight at every year, and I have the date when I took his weight. That's structured data. It's rows and columns. Something you put in Excel. Probably might be too big for Excel, but you can kind of put it in Excel. So then, Richard, what's unstructured data? Well, it can be multimedia. If I take a picture, I take 2 pictures, 3 pictures, that could be considered unstructured data. Because if I just take a picture of my dog's scale or my dog's height, I don't know how tall he is. I don't know a lot of this information. If I was just to capture the transcript of this classroom and put it in a big column, there's no section that says, hey, next week's homework is this. The introduction is this. The quote's this. It's unstructured. Approximately, and again, values change, but 80% of the world's data right now is unstructured. It's pictures, voice, video, big chunks of text, things like this. And then we have semi-structured. So semi-structured is more like a categorical. It's like a, hey, here's the title, boom. Here's, chapter 1, boom. Here. So it has some type of structure, but it might not be an Excel-based structure. So I think of it more like a tree, or like, when we talk about JSON or XML or these other formats, YAML, they have like a title and colon and what it is. Title, colon, what it is. If we think about a library, in my mind, a library is kind of semi-structured. So I know in a library, I don't know, maybe Q328, whatever that might be computer books. But I go to two different libraries, they're not going to have the same book. So to me, that's kind of semi-structured. Let's go on here now. Okay, there's another term, metadata. And metadata is the idea around the data. And for a long time, people might have thought that this data or this information was less valuable. But almost the exact opposite has happened. There's a story I read in a book about NSA, FBI, something. It doesn't really matter. And what they basically were saying is, hey, we don't need to capture the phone calls anymore. Capturing phone calls, because people can talk in code words, capturing the structured context of the call is not as valuable as most people think. What's more valuable is capturing the metadata around the calls. Who you call. And let me give you a prime example of this. This is from that book. I wish I could remember what one it was. But if two people, turn off their phone within 2 minutes of a cafe, and they do that again 3 months later, they're probably talking to each other about something sensitive or private. So if I was to go meet a terrorist, I don't know any terrorists, but if I was to go meet a terrorist, and I turn my phone off, I turn my Apple phone off, and then they turn the phone off a minute or two later, and then we meet up 2 weeks later, and I turn my phone off, he turns his phone off, the NSA or CIA or whatever three-letter organization can flag that as, hey, that's suspicious. And I think with that's a lot easier to parse, to go through, to analyze. Two people turning off their phone within 10 miles of each other, within 5 miles of each other, than millions of transcript logs. If, I take pictures of something, it has the date and time of when I took that picture. That's metadata. That metadata becomes valuable for analytic purposes. So when we talk about metadata, as we're seeing with ChatGPT and Claude, they don't necessarily capture, it depends on what version you use, but they don't necessarily capture what I ask. And they don't necessarily capture what the response is, but they capture what time I asked a question, what agents were called, and was I happy with the output. That metadata, that capture allows LLMs to generate better questions. I have another example, I think in week 9 or 10, where we generate an image and just a thumbs up or thumbs down. Even if I don't know what the image is, if I generate a thumbs up or thumbs down, that data, that metadata related to that image allows me to train better. And here's some more examples of metadata. Now, one of the things is cloud computing versus local computing. We can run an LLM, we can run software on our machine, or we can run it remotely on a cloud. Okay? But there's differences in terms of where the data is. If I have the data locally and I have to upload a lot of it, it becomes unrealistic sometimes. Or if the data's online, and I'm working locally, that might be unrealistic too. So sometimes you want to work a process as close to the data as possible. Is this okay? So that's the basics of part B. I'll make another video. This one's about 20 minutes. I'll make another video covering just the last chunk of week 1. Thank you again.